So, problem 15 has us look at temperature scales on a kind of fictional temperature scale, Jekylls and Hydes. And rather than doing that, I want to do the kind of weird one. It's like we use all the time that we're not aware of. How do you convert from Fahrenheit to Celsius? You can use your equation sheet if you want.
So Fahrenheit minus 32. And then times 5/9.
We use that. Where does this equation come from? We're just given it, right? We're just always told, like, this is how you convert. Or you could do the flip where you've got the times 9/5 plus 32, right? Come on in. So what I want to get at is this equation that we're just given, that we're just told is real, where does that actually come from? And it comes from the whole idea of why do we make plots in the first place. So when we make a plot, we're really trying to relate two things to each other. So in this case, we can relate our Celsius to our Fahrenheit. And in order to do this, we need some physical meaning, right? We're not just doing math now, we're doing physical meaning. So we're going to use water as our reference. So water freezes at
0 degrees Celsius.
0 Celsius and 32 Fahrenheit. So this can be our first data point right here, water freezing. 0 degrees, 0 degrees Celsius, 32 degrees Fahrenheit. Water boils at 100 Celsius and 212 Fahrenheit. So this is our second data point. With those two data points, we can make a line. You know, this gives us a relationship between Celsius and Fahrenheit. And I picked my axes in kind of an intentional way, so it's easy to figure out the y-intercept. Y-intercept. So what we're going to do is we want to come up with the equation of a line for this, relating specifically Celsius and Fahrenheit to each other. So in this situation, I've got Fahrenheit on my y-axis, I've got Celsius on my x-axis, and my y-intercept, because of the way it's set up, is just 32. So there's a plus 32 at the end there. And then we can also figure out the slope of this line, just doing rise over run. Taking the entire length of the line, we're going to have 100 minus 0 for the run, and we're going to have 212 minus 32 for the rise. This is like, what number is this? I think so. Double check. 180. So we can plug in this slope of 180 over 100 right here. Right, and if we rewrite this, we're going to get degrees Fahrenheit. 180 over 100 happens to be 9/5 degrees Celsius plus 32. And then if you want to get the version you had converting Celsius to Fahrenheit, you can subtract the 32 multiplied by 5 nines. But the equation that we've been using, the equation that's on your equation sheet, is fundamentally related to the properties of water and just relating these two things to each other. So what you have to do for problem 15 is essentially the same thing, except now you have to do Jekylls to I think it's just I don't think it does Fahrenheit. It just does Celsius and Kelvin. So you just have to do Jekylls to Celsius and Hydes to Celsius and come up with a relation between the two. Is this enough to give it a shot?
Yeah, I think so.
Okay. Go ahead, give it a shot, and then we can work on it together if we get stuck.